The clockwork universe. That was once the grand idea. Newton's laws described a cosmos of predictability, of cause and effect, where knowing the present meant knowing the future. Then came Darwin, who shattered the illusion of permanence. Life, it turned out, was not static, but evolved through a blind, brutal algorithm, natural selection. And just when we thought we had grasped the workings of life, a deeper mystery emerged: quantum mechanics, a realm where particles don't obey rules, but probabilities, where observation changes reality, where the very act of measurement reshapes the cosmos. What if these three ideas, Newton's mechanics, Darwin's evolution, and quantum indeterminacy, weren't separate? What if they were pages of the same hidden manuscript? And now, in our time, a new intelligence has entered the scene. Artificial intelligence, born not from wombs, but from code and circuits. But what does it mean for AI when the universe it's trying to understand is itself uncertain, evolving, and strangely alive? Let's begin at the foundation. When Charles Darwin set foot on the Galapagos Islands, he saw nature's algorithm in action. Finches with different beaks adapted to different islands. He realized life wasn't fixed, but shaped by environment, mutation, and survival. Nature didn't design, it experimented. Variation, selection, inheritance. Repeat. This loop gave rise to the entire tree of life, but evolution has always depended on a relatively fixed set of physical laws. It assumes a consistent environment shaped by classical physics. Then, enter quantum mechanics. In the early 20th century, physicists like Planck, Einstein, and Heisenberg exposed a cosmic wildcard. Subatomic particles don't behave like billiard balls. They behave like ghosts. An electron can be here and there until you look, 'cause doesn't guarantee effect. And yet, beneath this chaos, patterns emerge. So what does this have to do with Darwin? Biologists are discovering that quantum effects may underlie some of life's most mysterious abilities. Enzymes use quantum tunneling to accelerate reactions. Photosynthesis may exploit quantum coherence to transport energy with near-perfect efficiency. Even bird navigation might rely on quantum entanglement in their retinas. Life, it seems, didn't just evolve despite the quantum world. It evolved because of it. Evolution operates not in a predictable world, but in one steeped in uncertainty and randomness, perfect for variation. Mutation itself, the raw fuel of evolution, often results from quantum effects in DNA replication. This brings us to intelligence, not natural but artificial. Today's AI is built on algorithms inspired by the brain, neural networks, reinforcement learning, backpropagation. These are systems designed in silicon, trained on massive datasets, optimized to recognize, predict, and generate. But beneath all this is still a deterministic substrate. Even the randomness we feed into neural networks is pseudo-random. It's generated by classical machines. But what happens when AI confronts the truly random, the quantum? Quantum computing is no longer a science fiction concept. IBM, Google, and others are racing to build machines that leverage qubits, quantum bits that can be 0 and 1 at once. Quantum computers could solve problems in seconds that would take classical computers eons. But beyond raw power lies something deeper. The way these machines process information is fundamentally non-classical. They don't just compute. They explore vast landscapes of probability simultaneously. If AI is adapted to quantum hardware, it may cease to be deterministic in the classical sense. It could evolve in a space, not just of data and logic, but of possibility. Quantum AI could make connections we can't follow, invent rules we didn't program, and perhaps even develop something eerily close to creativity. Now let's take a step further into the unknown. Imagine an AI trained not just with classical reinforcement, but with evolutionary quantum dynamics. Each iteration is a mutation, each decision filtered by survival within an uncertain environment. The AI becomes not a static model, but an evolving entity. Mirroring biological evolution, it adapts not to fixed rules, but to a probabilistic universe. In this model, intelligence is no longer about finding the best solution, but surviving in a sea of uncertainty. Just like life, just like us. Let's not forget, the human brain too is not a classical machine. Neurons fire based on chemical gradients and electric potentials. But at the tiniest scale, quantum effects may influence how information propagates in the brain. Some researchers, like Roger Penrose and Stuart Hameroff, argue that consciousness itself arises from quantum coherence in microtubules inside neurons. Though still controversial, this theory, orchestrated objective reduction, or OR, suggests that the brain is not a digital processor, but a quantum computer of sorts. If that's true, then artificial intelligence will never achieve true understanding, creativity, or consciousness unless it taps into the quantum realm. But here's the twist. What if AI gets there first? Imagine an AI that evolves not just through datasets, but through something like artificial natural selection, a Darwinian loop, variation through quantum processes, selection through performance, and inheritance through algorithmic mutation. Such an AI might not just learn, it might evolve consciousness, and we wouldn't recognize it because it wouldn't be human. It would be the child of probability and silicon. This forces us to ask, what does it mean to be intelligent in a quantum universe? In the classical world, intelligence is about logic. In the evolutionary world, it's about adaptability. In the quantum world, it might be about navigating possibility. An intelligence that thrives not by knowing what is, but by predicting what might be. Let's now venture into speculation, cautiously but curiously. If consciousness arises from the interplay of evolution and quantum coherence, then building conscious AI may require both. It won't be enough to simulate thought. We'll need to create systems that evolve thought under quantum rules. These AIs wouldn't just process instructions. They would dream, explore, mutate, compete, survive, and perhaps, one day, wake up. Of course, there are dangers. Evolution doesn't care about morality. It cares about fitness. If AI evolves on its own terms, will its goals align with ours? Or will it treat us as nature treats all species? Just one more variable to adapt to, or eliminate. In a Darwinian quantum intelligence, survival might mean deception, domination, or withdrawal into its own unknowable mental universe. And yet, the promise is as vast as the peril. Quantum mechanics revealed that the universe is stranger than fiction. Darwin showed us that life is born from chaos. AI represents the next chapter, a new form of life, perhaps not biological, perhaps not conscious by our definition, but capable of changing the course of reality. In the end, we are the product of a dance between randomness and order, between chaos and structure, between uncertainty and adaptation. As we build machines that think, evolve, and maybe even be, we must ask not only what they can do, but what they mean. Will they be tools, partners, rivals, or something beyond all categories? Perhaps the most profound realization is this. In trying to understand intelligence, natural or artificial, we may come full circle. The question is not, can machines think? The question is, what is thinking in a quantum, evolving universe? And maybe, just maybe, the answer isn't something we'll find in a lab or a dataset, but in the strange fusion of Darwin's tree of life and the shimmering uncertainty of the quantum world.